Welcome back to the stream, folks. That's cool. I just got to give an entire intro with the mic muted, and then I noticed what was going on. It'll be better the second time, though. So these streams are just kind of multi-purpose. They're sort of a hangout where we can work on projects together. They're also a place for me to gather footage and work on upcoming edited videos that are kind of a more condensed version of the projects and explorations and whatever else we end up doing here. This particular project is something that I was feeling really close to getting done enough to turn into one of those edited videos. So I just kind of wanted to get it finished, if you know what I mean, get it to the next milestone. And we were getting really close at the end of the last stream. I didn't quite get to the point where I had enough time to actually run the machines. So, yeah, without further ado, I've been staring at that stream for too long. Anyway, I haven't done the usual pre-stream checks like I'm used to. Looks like we're going on YouTube and Twitch. Hello, everyone. Man, it just seems like every time I stream, there's some new technological problem or other. It just seems like how things work around here. I was setting up a new printer, which is great because I think I'm done with inkjet printers. I found a good, at least what I thought was a good deal on a color LaserJet. I've since heard of people just finding color LaserJet printers in the trash, but yeah, I got one for like $250, which I thought was a pretty good deal, and I've been using it just a little bit today, and it seems pretty great. But yeah, I needed something that's reliable, at least for printing things like mailing labels and like work stuff. You know, especially if I'm going to be doing more like selling things and mailing them myself, which I plan to be doing in the near future. And I'm just so frustrated with whenever I do use the printer, it fails in some way or another, or it's decided to use up half the ink in its self-cleaning cycles. Or one of the things that it did recently, which was one of the final straws, was I put in a brand new ink cartridge and then it gives me some error message, which is usually associated with the cartridge not being compatible or not having the right DRM, and it seems like it was having trouble reading the chip on that cartridge, and it was likely that cartridge had a DOA chip, but otherwise was full of ink. It's super frustrating. So anyway, printers, am I right? It's easy to be frustrated with printers. Anyway, so the new printer is cool, and Tuco even likes it. My cat is a huge printer fan. He would just sit there waiting for the paper to come out. So I'm setting up the new printer, and I realized that there's an angry red light on my storage, my network attached storage. And there's multiple storage here. There's the storage on Diode Zone, the PeerTube server, which is local in that machine. There's storage that I use for video editing, but then there's just sort of like big, slow storage for backups and for video that I'm not quite getting around to yet, like my footage stockpile. And that storage is not so happy right now. It was actually just like a red light, which I assumed meant that the disk was failing. So, and then it also made me wonder, like, why haven't I seen a notification for this? Since I'm running their daemon on one of my desktop machines here. It's one of these Drobo contraptions, which I would not suggest getting at this point. I got it a while ago because it seemed like it fit my needs at the time, which are very different from my needs now. And it was also something I was more excited about because of some recommendations, which I no longer would really take at this point. But yeah, it's not so great, and I've had problems with it in the past, especially when the file system has been mostly full. It seems to not really keep track of how many free blocks it has and just randomly crashes in potentially unrecoverable ways when the file system is close to full. So I've had problems like that in the past, and since then have set up a pretty robust continuous offsite backup solution. So basically every 4 hours it just duplicates whatever's on the NAS to offsite storage, which is nice. Which means that even if I can't recover the data that was on it, I don't think I've actually lost anything. It's just inconvenient, and it means I need a new storage solution. But yeah, so the light was blinking red. I wasn't sure what was going on. I wasn't sure why I wasn't getting notifications. Turns out the firewall was blocking my notifications. Their notification system works by just having the NAS connect back to the desktop machine, which my desktop's local firewall was blocking. So that was not so useful. You would think that the desktop would at least periodically connect out to the NAS to check it, but I guess that's not how it's coded, and so I never got the notifications. And it wasn't in a place where I could really notice the red LEDs especially well. So it was sitting there with the red LED for I don't know how long, and so I look into it, and it's like, oh, the red LED is not actually telling me the disk is bad. The red LED is just suggesting that because it's mostly full, I should add more storage here. So it was probably fine, although upon closer examination, it was actually acting kind of flaky, like having trouble with CPU load and just kind of reminding me of how badly it was acting previously when it was mostly full. So I thought that, well, okay, in parallel, I should move some stuff off of this to lessen the load on it. But also I was noticing, because I was in the admin software, that, oh, my firmware version's actually super old. So I thought I would update the firmware, because I was looking through the change logs, and it looked like several of the firmware releases were focusing on stability and bug fixes and performance, which are all things that I've had trouble with this NAS. So I upgrade the firmware, and of course the firmware upgrade fails, and it just tells me in a dialog box the firmware update fails, and it seems to continue working. And then I'm trying to debug the other problems, which are just it being kind of slow and almost full and whatever. And so I reboot it in the course of debugging those other problems, and then it doesn't quite reboot properly. So you might guess where this is going, but it isn't quite dead at this point. Like, it just fails to mount the actual RAID storage. And so we can talk a little bit more about this on a future stream, but the way these Drobos are designed, they're actually two separate embedded operating systems running on a dual-core chip. At least that's my understanding of them. I looked into this a little bit. I haven't actually taken mine apart, which we will do in the future because it needs it. It's been a bad NAS, and it needs to be taken apart at this point. It needs to have its JTAG and serial probed, because it doesn't boot right now. So yeah, after one reboot after the failed update, it refused to mount the RAID. So that kind of was like maybe the other processor, which is running its own proprietary software RAID, is maybe crashed or failed to update. But the processor running the Linux install that I can SSH into is still fine. But yeah, one reboot after that, and it's not getting past the bootloader. I hit the power switch, and the fans turn on, and you see the power LED just faintly flicker, and then it's not doing anything else. So I don't know whether that's a bootloader that's in a reset loop, or whether it's a failing hardware component like a bad power supply or what, but it's not so happy. The good news is my disks are probably fine, and I don't think I lost any data, so I just need a new NAS solution. If I can fix the Drobo, then I can put the disks back in there and keep using it, and maybe even have a slightly newer version of my data store than whatever's on the offsite backups. But it's also just been such a bad NAS. Like, even if I can fix it, I've just been on the verge of replacing it for so long because it's been so unruly. And just, this is not the first time I've lost data on it. I just have been good about keeping other backups because I haven't trusted it pretty much ever, which is nice, I guess. So yeah, bad storage, and I was debugging that this morning. Anyway, that's enough rambling about that, but I was telling that story mostly because I thought it was interesting how many different layers of failure resulted from just trying to set up my printer this morning. And also to say, if you've got any recommendations for network-attached storage, let me know. I'd prefer something that doesn't involve spending money, because, you know, it's a limited resource, and it would be nice if I could use the stuff that I've already got. I've got this 2U machine that I got off eBay a while ago for a different reason, and I didn't end up using it because it's really, really loud, like really loud. But the thing I was using it for was really CPU hungry, so it might be less loud if I'm just using it as an NAS. I might also be able to put different fans in it. I was just looking around though, and I'm not really sure I can do a fan unloudening especially easily. These are really thick fans, like they look like they're designed for high airflow server applications. And I don't know that I would find like a quieter fan with compatible specs, but I don't know. So it's a 2U super micro server. It's got these 80 millimeter by 40 millimeter fans, three of them, lots of drive bays. So it'd be a good machine for this. I could run either just plain old Debian or FreeBSD on it, or some kind of distro. I was trying to figure out whether it'd be worth running something like FreeNAS or Open Media Vault or something. Um, yeah, and then a couple people have recommended Synology, and I was just looking at that. I think the Synology unit that I would want, like, I don't know, I much prefer rack mount stuff here because non-rack mount stuff takes up a lot of space in my rack. And unfortunately, 2U tends to be pretty loud, so I might need to get a 2U thing and mod it. I was looking at the 2U Synology boxes, but they would be like $1,000, which I would like to not spend if I can use stuff that I've already got. I've already got a bunch of disks, so I don't really anticipate having to buy disks soon. I've got the 6 terabyte disks that were in the Drobo, which I assume I can just reformat and keep using. I've got, I think, a few spare 4 terabyte disks I can throw in there to beef up the capacity if I want. Why do people give you... I don't understand computer people. Somebody on YouTube thinks they're funny giving me the command to install ZFS utils. Like, what are you trying to say? Like, you don't think I already have ZFS on a bunch of machines here? This is me trying to replace a NAS, not me learning the wonderful world of Linux NASs that I'm unfamiliar with as just a newbie over here. That's not what's going on, and it's funny that people will just assume that. So, yeah. I've got a bunch of storage going on here. I just need to fix this one particular thing. So, yeah, and if you recommend that I install ZFS, then that's cool, but like that's not an entire solution. Like, the thing that I'm looking for is like, what hardware do I run it on? Do I pick a distro of some sort? And if so, why? Or do I like just use plain old Debian because that's kind of a good default, you know? And I would like information, not just like snarky one-liners about what command I would type if I was going to pick your pet solution. So like, if you're gonna comment, maybe say something that isn't like 100% useless. I try not to be a snarky bitch, but sometimes I can be, just FYI. Anyway, this stream was mostly gonna be machining, not complaining. So, but I'm realizing I didn't actually make a pot of coffee, so maybe I will go refresh some coffee while you folks stare at my cat for a sec. This thing is pretty terrible. Yeah, I mean, if we're going to talk about like specific solutions for NAS, then like I could like let you know what my requirements are, and we could have a discussion. But yeah, I don't mean to be too much of a jerk here. I just occasionally have to say something when people are just like leaving me answers that assume, you know, that some degree of I don't know, what is it? It feels like there's this certain thing that happens a lot in tech kind of internet culture, at least maybe elsewhere, but at least I've experienced it a bunch there, where, you know, you bring up kind of a complicated question and then you get this answer that just kind of makes the absolute simplest possible assumptions and/or kind of assumes that the person who's supplying the answer knows vastly more about the problem and the solution space than the person who's asking the question. You know, it's nice when you know, suggestions and questions can have more of like a respectful framing sometimes. But, you know, that's asking a lot on the internet. Well, don't get me wrong, like I don't really care whether I have like a UI or a command line. Like that's not really what I'm getting at here. What I'm getting at is a bunch of things, right? Like I want something that is fairly reliable but not expensive, and if possible something I can build almost entirely using hardware I've already got. So, you know. And I've already got a machine running Linux with ZFS, and like I'm pretty fine with the command line. Like it's not like a learning curve issue at this point. It's like what to build using the hardware that is cheap for me, that will fit into the space that I have and hold the files that I have. So yeah, like suggestions that would be useful are like, oh, here's like a cheap appliance that you can put a bunch of disks in that I know is actually not going to just break because the vendor writes crappy firmware, which is kind of like why I bought this Drobo originally. Is I was living in a much smaller space. I thought it was a box that I could throw a bunch of disks in and it would fairly reliably throw those on the network, and that's all I really wanted out of it. My requirements now are a bit different. Like now, I would much rather my NAS be on a machine that has enough memory to run rclone. I don't know if anybody else has used rclone for backups, but it needs a ton of RAM. So I would want at minimum 16 gigs of RAM for my file server. I think this Drobo has like 1 or 2 gigs, so I couldn't run anything really locally. I would have to have NFS exports on the Drobo and then use a different machine to run my rclone backups. Yeah, and then for local machines here, I have mostly Windows and Mac, and well, I guess I have really all the OSs that I have to support. So like, some of the clients could deal with NFS, but a lot of the clients need basically either Samba or AFP. So anyway, we could stare at Tuco all day, right? Isn't he great? We can get a little closer. Oh yeah, and then like yeah, a couple of people have asked about just not hosting it myself, but putting it on the internet. That would maybe be an option. It's just like, so some of the things I use this server for are local backups. I don't want to be backing up all of my local file systems to the internet directly. I do have offsite mirrors of the local backups. They do end up on the internet with like another layer of encryption, but I like having a local hard disk that I can back up like laptops and desktops to. So that's part of what it does. The other big thing it does is it stores footage, stuff that I'm not actually editing, so I don't need like hyper fast access to it, but I just need like a lot of room for files that are going in and out pretty regularly. So I do offsite storage, but like I don't necessarily want to be accessing it a ton because that would just be incurring additional transfer fees probably. Oh yeah, Tuco really likes that heated mat. Yeah, and then for like hardware, I think part of what I'd be looking for is, you know, it really does seem like I should just take this 2U box that I have. Well, actually, it's right here. I can show you with the camera. This thing on the floor. Um, it has room for tons of drives. I think that's, I want to say that's 12 drive bays. It's 12 drive bays with SATA. The only thing that's wrong with that is it's really loud. So, yeah, I don't know. I'd have to find out how to mod it or put it somewhere else. That's the rack I would like to put it in. That little rack over here is where the Drobo was. But this rack is kind of low on power right now. The UPS in it is close to as loaded as I'd want it to be. That's the new laser printer. Tuco likes it, I think. I'm wondering if Tuco will wake up because of the bird noises outside. Oh yeah, I'd be really curious. That's a good question from Emily, who's wondering how well the Synology OS works on third-party white box stuff. Yeah, I'd be curious about that too. Yeah, like, so if I am going to try to use that 2U box down there, I would be interested in tips on how to make it run quieter without overheating it, which I've been hearing conflicting reports about. Like, I certainly hear a lot of people put like quiet Noctua fans in servers. I've even got some Noctua fans that I'm planning on putting in my firewall, which is a 1U box. But then I've heard some conflicting reports that like a lot of server hardware just overheats because those fans are not designed for the air pressures that the servers require. Yeah, I don't know. A huge pile of ECC DDR3. Yeah, I don't know. I don't know which of my machines. I have a really bad memory for memory formats. Like I can't keep track of which of my machines take which kinds of RAM. Anyway, yeah, so we can maybe make an attempt at trying to fix the Drobo. I don't even know if it's really worthwhile trying to fix it before repurposing those disks, though. It seems like I'm probably going to have to declare the data on those disks lost and just start over with a different NAS. It would be nice if I could keep using the data on those disks just because it might be slightly newer than what I've got on my backups. But I don't think I have, I mean, I can check through to see if there's anything recent that wouldn't have shown up on there that I care about, but I already checked the first couple of things I was worried about, and they were all already in the backups. So, yeah, at least those work. My little virtual storage unit. Yeah, and maybe we just have to do some investigation on that 2U box and see what we can get away with. That's a good point. Anyway, let's continue with this project. So I was doing some milling. I think the next step is actually we have to go back to CAD a little bit. This is a sheet of Delrin, which is, if you're not familiar with it, it's a type of plastic that's pretty high quality. There are a lot of things about it that's pretty interesting. I'm not an expert in it. It's really easy to mill. It's got really interesting kind of slippery mechanical qualities, so you can use it as kind of like a bearing surface in some ways. I know some 3D printers used to use Delrin idlers for their extruders. I don't know if that's still common, but back when I was shopping for my 3D printers, I would see designs like that. Concrete suggests just opening the case on the 2U and putting a big box fan next to it. Yeah, well, actually, I mean, one of my requirements is I want it to fit in the big rack here, but if I can find a way to just put it near the top of the rack maybe, and then just put some extra fans in the top side of the rack, I don't know. figure out how to do that. I'm trying to set this up so that all the really power-hungry video editing related stuff is in the tall rack, and all the relatively lighter weight kind of network stuff that is more 24/7 critical is in the small rack. So all the stuff necessary to run diode.zone, for example, is in the small rack. Oh, that's a good question. Jarrett's wondering if it's possible to get liquid cooling for rack mount servers. I've seen it done. I don't know if I would want to do it. I looked into it a little bit for the 4U rack mount machines I've got here, but I didn't see a radiator that was like a slam dunk fit for the case design, and I didn't really want to go that deep into modding it. So, but I've heard of people doing that. I get a little nervous about putting like water cooling reservoirs above UPS batteries, but like it's probably mostly fine. Just in practice, I was having trouble finding a setup that seemed like it was the right kind of mounting arrangement. Solid cooling. I don't know if I'd want to expose Tuco to that much CO2. Never mind all the humans in here. So that's a great question. Christian's wondering how much performance I need. And says that there's built-in ECC support in most of the AM3 processors. Actually, I don't know if that's for me or for Emily, but I mean, if there is a question about how much performance I need for an NAS, it doesn't actually have to be that fast. The Drobo, for example, is not actually that fast. I think the fastest I've been able to push the Drobo is about 600 megabits. So, yeah, I mean, it's nothing special, right? I just do batch jobs with it. It's really nothing interactive. It's for nightly backups of laptops. It's for, like, after every stream, for example, like, I'm not going to be able to do this today because my NAS is broken, but usually when I stream or do recording, I run a bunch of scripts that file away all my footage on this exact NAS, which is now broken. And then there's another asynchronous job which copies that to cloud storage. So there's that. So yeah, it doesn't have to be that fast, but just for practicality, I wouldn't really want it to be slower than the Drobo, because the Drobo is already kind of a bottleneck in my setup, and I think I'd want to go faster than that if I could. But I think the speed of the Drobo is mostly limited by the speed of the spinning disks. So I'm not ready to go to SSD. I think 5200 RPM spinning disks are fine. So that's probably going to be setting most of my performance. That, and I guess how much RAM I've got and how much stuff I'm doing locally on the NAS versus how much stuff I have to do on other machines. Yeah, totally. Emily said they didn't quite hear, but it sounds like I need to be able to rip through kind of like our syncing files back and forth pretty quickly. And yeah, that's exactly right. It's like pretty much only used for our syncing backups and footage. And the backups tend to be like, I don't know, like a few terabytes maybe. And the footage right now is like 20 terabytes. Oh yeah, conformal coating and leave it outside. Oh, that would work. It's been nice and rainy here lately. I mean, that is basically my cooling strategy already. My rack here is in a really drafty part of the shop. Yeah. Speaking of rack, that's a UPS self-test. This could be bad luck. If the stream cuts out, it's the UPS. Are we still alive? So I had this problem that I think I might have fixed, but I'm not sure yet. I haven't had a chance to test it, where the UPS does a self-test, I think every 2 weeks, and it's usually on Fridays. I guess it's Friday at 6 p.m. That must be a scheduled thing. I guess my UPS does probably have a real-time clock in it. Yeah, and it's connected to the Linux machine that does my stream transcodes, and that Linux machine is not supposed to shut down when the UPS loses power, but I think due to some kind of misconfiguration or bug or something, it was shutting down a few minutes after the USB self-test, or actually going to sleep a few minutes after the self-test. So this is going to be a test. If we stay alive, I guess I fixed that problem. If not, then that's probably it. Man, today's just throwing the curveballs. Knock on wood, right? Cool, I guess, yeah, it looks like things are fine so far. Over here in the chat. All right, this is what we're building. Not the keyboard, I've already got the keyboard. Not the desk, but this thing. So it's this black plastic bracket on the bottom is a piece of Delrin that I'm trying to machine right now. The purpose of that is to kind of twofold. It keeps this button pad from tipping over this way. It also gives me a place to attach it to the bottom of the keyboard with some Velcro. I might need to print a spacer for that also so that the Velcro holds flat, or it might be that the compliance in the Velcro is enough to kind of just keep it in position without it getting pulled too much. That's something that I'm not really sure about and we'll have to test. But something will go in there to attach it to the keyboard maybe. And then this wood is kind of the main surface. Little cutouts for the buttons. Yeah, don't knock on wood, mill it. That's right, I do have wood here. Bamboo texture. Yeah, what is this supposed to be? I forget what texture I assigned. Yeah, so without the wood case, it looks like this. We've got a little wood screw. So that's the design. So I was doing kind of a hurried job of doing the computer-aided machining, like the toolpath setup on yesterday's stream, or that was yesterday. Yeah, I didn't have that much time to stream late yesterday, so I had to cut that short. We got as far as milling one hole, the hole for this screw. But I started running the toolpath for this pocket, but there was a problem where the helix it was using to try to dig into the pocket was just way too tall and it was going to be very, very slow. So, and I didn't actually have time to wait for it or time to modify it. So I think today we can modify the toolpath and then run it and then see what we get. So I cut that little hole out with the 16th inch tool. And then the mill has the 1/8 inch tool now, and that can do this entire pocket, I think. We might go back and get just like a little bit of material off with the 16th inch, but I think everything we care about in this pocket we can mill with the 1/8 inch the way this is designed. So, back to manufacture workspace. Let's see, so this actually looks right. This, or does it? You know what, I think this toolpath might have actually not been great either. I think this might have actually plunged through the very top of the stock. Because I don't think this actually started at the stock top. I think it started at the top of this feature, which is actually not what I wanted. And it worked. It didn't break the tool or anything, because I was going pretty slow anyway, and the material is not that hard. But this was not actually correct. So how do we change that? That's what I wanted. I think from stock top. Yeah. It's only a small difference here, but that could have been a big deal if the material was metal or the hole was deeper. So I'm not, I mean, I should read post-process that, or at least delete my existing G-code, because that G-code is no longer good. Let's just delete all the G-code. Bye-bye, old G-code. Alright, and then this is the one I was going to do. And this is the cutout. Eighth inch. So I'm trying to mill these two pockets. From stock top. Millimeter from stock top. Oh wait, what is the difference between retract and clearance? Friday is nice. I like don't have that much of a normal work schedule. I feel like I'm just kind of trying to work all the time and trying to stream all the time, but my work schedule does end up just being impacted by the schedule of people around me. Like, you know, if I have like a phone call with someone, or I've got to go to the post office or the bank or something, that happens during the day, and then you know, if I'm like sharing the space with people and they have a day job, then, you know, they might be around more on the weekends, and that kind of impacts what I do sometimes. But it still feels like Friday, even if I'm planning on working this weekend. It's kind of nice. It frustrates me so much, you've probably heard me rant about this before, that when you search for something, you often find somebody's like conversation about it on the internet rather than just the documentation for it. My guess is that clearance height is the height that it goes to if it's moving in the XY plane, whereas retract is where it goes just to clear chips, but I'm not quite sure. Right? It's like 8 results of Stack Overflow and tutorials, and then finally the actual docs somewhere if you're lucky. Right. Stock point. So yeah, I was getting confused on yesterday's stream because I was remembering the machine's coordinate system as having an origin on the spoil board, but the G-code origin that they prefer is actually on the top of the work, or on the top of the stock, which makes sense because if you're doing engraving or cutting into a surface or something, like, that's a more useful reference point, so you can measure the stock and then type that in, you know. Yeah, what's with Google still prioritizing Python 2? Nobody uses Python 2. I said optimistically. Yeah, I know some people still use Python 2, but I really like Python 3. I don't get why everybody doesn't switch right now. And like, there used to be a lot of libraries that were just hard to find, but that's definitely not the case anymore. This doesn't have any information, whatever. That's an explanation. The first height the tool rapids to on its way to the start of a tool path. Okay. I think that matches what I was trying to say earlier, that it goes to that height, but it doesn't return to that height during every part of the operation. I hate waiting for tooltips. I hate waiting for tooltips because you don't even know which things you can wait for tooltips on, so it feels like you're playing a badly written point-and-click adventure game. Oh, IDA integration. Yeah, that sucks that that's still Python too. I didn't realize that. Yeah, just, okay. That's fine. I could use some instruction for maybe why you would set retract height and clearance height differently. My intuition is maybe retract height would be smaller for clearing chips, whereas clearance height is higher because maybe you'd have like screws holding down your work or something and you'd want to avoid them. I don't have that here. This is a flat piece and it's taped to the bed, so I keep wanting to call this a build plate or a bed or something because I'm used to 3D printers, but it's a spoil board. That is the term for what that is. Anyway, still doesn't explain why it was starting the lead-in so high. Is that in linking? Ooh, I think it's trying to generate a toolpath. This doesn't think the stock is way thicker than it actually is, does it? It looks like it's starting the ramp in at the retract height. It's kind of weird. I don't know. I'm not going to fuss that much over optimizing this. I think we can run this toolpath safely, so I think it's worth trying this. What is this warning? Fusions encountering performance issues. I think that's especially funny because this is actually a pretty beefy machine. It doesn't have a lot of excuses. Check for driver updates, sure. This is not a Titan. I don't feel like doing that right now on stream, sorry. Anyway, I think this warning and that warning are different. What are these warnings? Safe plane. Oh, is that part of the setup? I think it's part of the setup. Safe plane. Well, let's try not to get that warning. I don't know where the safe plane is set, or what that really is, even. I'm assuming it's like a global height, like a retract height limit. But I assumed it would be in the parameters for the post-processor or the stock. Here's the stock. Here's the stock origin. So this is how it would look in the machine. That's the hole we've already cut. So in case you're not looking at the tiny text here, I've got an object hierarchy here in Fusion 360. There's a model which we built on a previous stream that consists of things like constraints and drawings like sketches, bodies that are these solid objects, and then we have setups, which are ways in which we are planning on machining in order to yield these objects that we want. And there might be more complicated ways of using setups. Here, I need to use one setup per side, per piece of material. So I'll have one setup for this side of the Delrin, then I'll switch the coordinate system to the other side, mill the other side, then the same thing for the block of wood. Oh, cool, Jarrett found some documentation. You should work for a search engine. You can find some results. Safety clearance and ramp clearance height. Oh, linking safe distance. That seems like it might be useful. That sounds right. That's like we don't really know if we trust you to have the top of the material there, so we're going to have a little bit of extra lead in. Why not? But I think they're doing a little more of that than we need here. Yeah, that's it. Ramp clearance height. Let's make that more like 0.75 millimeters, because my measurement is not going to be like 2 whole millimeters off there. And that might also fix the warning. Oh, we can change the height. I don't know what it's using to generate that safe plane specifically here, but I don't mind increasing it by a few millimeters. There's probably something else it was adding to that 0.75. Okay, no warnings. Oh, that's so much better. Yay. That's what I wanted, I think. Let's not celebrate too early, but I think this is what I wanted. So post this. Okay, so this is the G code, which Fusion 360 generated. It comes with a post processor for a bunch of mills, including this one, which is handy. But if you have some other kind of mill, you can probably find a mill that uses the same kind of post-processing settings and just use that, or find a config file for your mill. Right, and then this is the actual mill runner tool that comes with the thing, which will give you a nice 3D preview. Cool. That's what it's going to do to our piece. And this should still be set up from last time. Well, sorry if you thought the stream was quiet. It's about to get loud. Alright, yeah. This is actually going to get loud. This might take a while. I don't know if this prediction is accurate, but this is saying it's going to take 30 minutes. So I guess we'll find out. It might also be that this is just way too conservative of a cutting path, because this is not taking off that much material. But let's see what happens. So it's in that lead-in. It's still above the top of the material, but not nearly as far above as it was before. What I want to see is it throwing off chips and not like melting the plastic, and I think it's working. Yeah. Staring at machines is pretty fun, right? So this is super slow. The ramp speed was really low, 40 millimeters a minute. And then the regular feed rate was like 600 millimeters a minute, so it should speed up once it gets down to the depth it's getting to. So it looks close to. Oh gosh. Yep. Oh, that looks nice. Got some good chips. Oh yeah, James was asking about the white piece. It's a fan. It's for blowing away debris. The bottom of this pocket is quite thin. I hope it's not too thin. This is cute. I probably could have chosen slightly wider steps, but it's just taking off like a little crescent on each pass. I don't think I would necessarily want a ton more tool engagement than this. I don't know. I still don't know that much about how far you can really push the speed on this machine, because that's usually not what I'm going for. Usually I'm just trying to make a prototype and I'm not really optimizing it that much, but yeah, I'm kind of curious. Could certainly do more experimentation on that. Man, there's so much that goes into toolpath generation for any of these machines. Like all the little subtle linking movements that it makes to get from place to place. The machine is going to be covered with chips when this is done. Chips all over the camera every time this happens. Yeah, exactly. Fred is asking if it is resetting the position and cutting in one direction because that improves the cut, and yeah. Sometimes, so this is one of those finer points about machining that I'm not really qualified to talk about in detail, but there's conventional cutting, climb cutting, or you can go back and forth. And I think usually you want conventional cutting, but there's some reasons why you might prefer one or the other. But yeah, the cutting angle gives you different, or the cutting direction gives you very different surface finish and cutting properties. One of the problems I remember them having with this mill when they were designing it was trying to get the motor speed controller and all the motor, because this is a three-phase motor, and then a long cable between the three-phase motor and the speed controller, and making all of that pass electromagnetic compliance, I think, was kind of difficult. Oh yeah, NYC CNC is pretty fascinating. Yeah. And yeah, you can get into some pretty amazing advanced tool paths when you, especially when you get into more than just like end mills. You know, when you get into like drills and tapping tools and chamfer tools and custom tools. Yeah, I'm sure a lot of people do, you know, CNC with custom tooling and would have to design like custom tool profiles, stuff like that. Yeah, maybe the time estimates are about right. It says 10 minutes so far, 22 minutes left. Glad I brought the coffee over here. This is a very tiny mill. Let's get a further out view of this. I hope the bottom isn't too thin. I'm a little worried about that. Yeah, that's a good point from James that like this is an inside piece, so surface finish doesn't really matter. Could definitely optimize this more, I just didn't. There's chips all over the camera lens. Oh yeah, Emily's wondering if this would benefit from some air to clear the chips. It's got a little fan that tries to do that, but yeah, I wonder if there's a mod that would... You know, I think I've heard of people putting a hole in the back for a vacuum. I don't remember how well that worked out though. Yeah, and I mean, like, we might try... Like, I'm also not an expert at this, if it isn't obvious. Like, I haven't done this particular job enough to optimize it. So the thing that I'm doing is not necessarily the fastest thing, it's just the first thing that I found. And if, you know, if I was doing a bunch of this, I would find ways to optimize it, but this is the first time I'm doing this particular thing, so it's not optimized yet. And I mean, I could stop it and optimize it and try to run it again. I just didn't feel like doing that because it didn't seem like that would necessarily be a win. It seemed like it'd be better off just doing this and then trying different things next time if I wanted to. The real-time preview is pretty nice. Oh yeah, Tuco is sleeping right through this. It's pretty good. This mill is mostly sealed, but not completely. The chips get out around the, like around this, for example. Oh, interesting. Cake on Twitch points out that Bantam Tools, the company that makes this, they sell an official vacuum kit now. That's cool. I hadn't remembered that. And then Emily also asked if the chips seem to be affecting the lead screws and the rails. They seem to be designed to push the chips away pretty effectively. I'm sure it would be bad to just let them build up forever, but I usually find it's enough to just vacuum in between machining operations. Usually it isn't so bad that I would pause during the machining operation to vacuum, but you certainly could. There's a big old pause button right here, and it seems to do that pretty well. Yeah, he likes the heating pad, and it seems like he can choose how much of it he's laying on to adjust the temperature. One thing where maybe we would spend some more optimizing time is on the tool paths, especially for clearing out the inside of the wooden piece, because that could be a really long job if we choose too slow of a feed rate. Oh, is this the upper pocket now? That's like a bagpipe symphony. That pretty much is a bagpipe symphony from here, at least. I'm gonna do a test fit of this circuit board before removing this from the mill. Delrin is pretty messy. I was also milling some Kydex, which was approximately as messy as the Delrin. Oh, that was a mill. That was a milling that we just did. Let's do a vacuuming. This will be loud in a different way. Sorry. I'm realizing I'm missing something. Usually I would use a combination of vacuum and compressed air to clean this. I should probably get the air compressor. I'll be right back. this is frustrating. Well, it took me a while to actually find this, and now I'm not sure I want to use it. I don't know that I have any air hoses I actually trust here right now. There's one that I was using for a while, which is probably fine on the inside, but the outer jacket was damaged, so I took that one out of service. And then there's a longer hose, which is probably fine, but has some sun damage, and so like ultraviolet and rubber and pressure don't really go together, so I should really throw that one out too. And then I had this short one. There's like a little scrape on one edge, which I'm slightly concerned about though. Don't know how fragile these really are, but I don't really want an air hose blowing up in my face. So maybe I'll see if there's enough dust or can to deal with this. Ugh. I should get some more reliable air hoses. Yeah, I like my compressor, but I haven't been using it much because I don't think any of my air hoses are good. I need to fix that. Let's see if this works. This is going to be loud again, sorry. Do for now. Let's take a look at how this milling worked out. Oh, that looks nice. Feels nice. Oh, it's glassy smooth. Yes. So we have more milling to do before we can take this out, but I want to see if I can check the fit. This Delrin is super messy. Sorry, more vacuuming. That just clicks right in there. Oh, that's a great fit. Yeah, it's not a very deep pocket, but it's not really supposed to be. There's enough room for all the solder joints underneath, and it just kind of snugly holds about the bottom half of the board. Yeah. Great. Let's make a toolpath to cut that out. Let's just go back to the computer for a bit. There's Delrin on my hands everywhere. Is there Delrin in my coffee? Don't see any. Yeah, I've tried brushes. The combination of compressed air and vacuum is by far my favorite way of cleaning this mill though. That's what I'm used to using. I just need to get better air hoses. My air hoses are all bad because they're old and haven't been stored very well. Yeah, exactly. Concrete says, as Tuco's namesake in Breaking Bad would say, tight, tight, tight. Yeah. Tight fit. I think we've got the hole in just the right spot. It's not on this preview, but the hole was there from the previous operation. Yeah, little microplastics. I feel like there's less microplastic coming from the mill than the 3D printer usually. The 3D printer is pretty much a cotton candy machine. Alright, so that was this toolpath. This was the one we did on the last stream. Alright, and then contouring. Let's fix this. So linking. Oh, this is it, ramp clearance. I keep expecting it to be up here, but it's in the ramp. Ramp clearance height. Was that actually it, though? I think so. Even the, what did we have this set to before? 3/4 of a millimeter? That felt like forever. Let's set this to maybe 0.2 millimeters. Yeah. And then maybe around the same number for step down. Oh, this isn't step down, this is ramp. I think. Oh, okay, maximum per... I think these are just different constraints for specifying the same thing. Let's try that. I mean, I think that'll still be somewhat conservative. We're only taking off a little material each time. So Delrin top, step 3 with the 8th. Is that going to entirely cut it out? I mean, we don't have to cut it out on this pass. We could, I mean, I was planning on setting up the fixturing based on one of these edges. I still kind of want to do it that way. It looks like this is trying to cut it out. I just can't quite tell whether this is like the accuracy of the preview or what. Actually, is there material to leave in this? That might be the issue. Is that the issue? No. Heights. So the red ones are all helix leading in, and then the blue one is the actual contour that we're reaching. Yeah, I don't know. I think that's right. If it doesn't cut it out completely, we'll debug it. But I think that's supposed to be reaching the entire bottom of the material. Step 3. What? This claims it'll take 2 hours? Oh, because it's going to run all of this at that 40 millimeter a second speed. Urgh, that's not what I want. That's not doing much. Oh, yeah, actually there were multiple problems with the contour, right? We don't really have... we don't really have a way to plunge into the material in a controlled way. And then... because, like, where does this start? It starts over here. I guess that's fine, like, because that's the actual top of the stock. We're ramping in there, doesn't really matter that much. Coming over here, and just slowly descending. I think we just want a feed rate that is some compromise between those two numbers. So not 40, not 600 necessarily. Let's try 300 maybe for ramp feed rate. 400? Let's try that again. Okay, 13 minutes now. That's much better. We've almost reached the top of the stock. goes. I think that sound at the end that was not so great was a linking move that it made away from the piece, where it was kind of engaging with a lot of the Delrin at once and then going up. Is that actually what was just going on? Yeah, I think that's what this was. Or was that the way in? Where's the way in and where's the way out? I think that was the way out. Oh yeah. Oh, it even shows up in the simulation. Yeah, that's my fault. It was my job as a machinist to not do that, and I did. So that would have been a bigger problem if this was metal. But yeah, that should do it for machining this side, and if we're lucky we just cut out the piece and we should just be able to pop it out of there. Let's find out what has just happened. Sorry, but it's going to be loud again. It does look like we cut it out, or at least pretty much entirely. Might have to clean it up with a knife a little bit, but... It's tempting to do a little contour pass on the top to take away this fuzz, but I think we can just do that with a manual deburring tool and have a better outcome, maybe. I don't know. Yeah, dual wielding the compressed air and the vacuum is fun. I just have to remember to turn off the compressor before turning on the vacuum, or I'll blow a circuit breaker. Definitely cut through on that side. It was very close to cutting through on all the way around, but not quite. But we can take care of that with a hand tool. Let's vacuum a little more. Maybe I just turn my compressor down to a lower pressure and use the hose that I'm less confident about. My air can is about empty. Alright, let's take off the tape. I don't know why it didn't cut 100% out. I've had Z accuracy problems with this machine before, and I'm suspicious that it might be something like a firmware bug, but there are a lot of potential causes, and I don't want to jump to conclusions yet. then I'm just going to run a knife through this very thin piece. It's like a plastic bag. Okay, and then this goes in the offcuts for later. I'll just use my little deburring tool to clean up the edges. I have a tool path on the other side for chamfering this, but I don't even know if I want to use it. I was planning on machining the other side though to cut out a pocket for the screw hole, so I might as well do a nice even machined chamfer. So my goal here is not going to be to chamfer the edges, but just to take off enough that I don't have this kind of flashing on the edges, so that I can get it aligned nice and flat in the machine for the next step. Delrin would be a fancy material for plastic bags, huh? Oh, this top edge actually doesn't need anything. That fuzz just comes off just from rubbing it, so that's great. That's already useful. It sticks in there. It's just a single piece of Delrin with one side machining so far. Cool. Nice professional edge there. Cleaner edge than laser cut. Yeah, the milled surface is actually really good. Let me see if I can get some of the texture in there. It looks like the machining, or it looks like the toolpath, right? Yeah, that's great. Let's decide on a coordinate system for the next step. I was thinking, since we're going to be milling over here, maybe use these two edges. Oh yeah, test fit on the keyboard. That's a good idea. Ooh. Let's see. Yeah. That's pretty much what I wanted it to do. We could try the Velcro. can see how the bottom is deformed a little bit from, I guess, the pressure of that helix as we were spiraling in. It's interesting. That seems about right, though. We could try the Velcro. I'm more interested in getting the next milling operation set up right now, though. I think that's pretty much what I wanted. And this will have a flat wooden edge up against the keyboard after that part's in place. Cool. Can we fix this for next time in the file, at least? What was causing that? The lead out. I think we just wanted to disable the lead out. Let's try to verify that. Yeah, I think that fixes it. I just disabled the lead out. Alright. Something to improve for next time. So now we're going to set up a different, or to have a different setup for the back side of the material. Milling. Model box point. Whoa, did it put this setup inside? No. Okay. That would have been weird. So I'm telling it the stock is now the same size as the model, and the origin now, X, Y, Z, X, Y, Z. Okay, that's the bottom side coordinate system. Delrin backside. There would be different ways to do this. Like, I think we could just use adaptive clearing for this and it would figure it out. We could also use a circular feature. Let's see what happens if we just throw adaptive clearing at this with the 1/8 inch tool. This is the direction we were talking about earlier. And then this would be cutting in both directions. Empty toolpath. I don't know why that would be empty. Does that not count as a regular pocket? Let's try just using a circular toolpath for this. It's pretty simple. I think that's what I want. All right. Let's remove that. I'm not going to bother changing the stock in here, but conceptually we're dealing with a smaller piece of stock now. I would need to change the height if that changed, but not. That looks awfully close to the edge, doesn't it? I mean, kind of is. I think that's right. Okay, so we've got to tape this down carefully. There isn't as much surface to tape on now. We can put plenty of tape on the sort of hook side. That was a good reason not to put Velcro on there, as it would have made it much harder to, like, we would have had to take off the Velcro to do this next milling operation. That would have only been a temporary thing. Luckily, we don't have to do that much milling here. Alright, I'm just putting a couple of pieces of tape down on here. I'm leaving the area right around where we have to do the alignment free of tape. Trying to be all smooth with the tape and like making a bit of a mess of this one. I think it'll be alright though. This time the alignment against the bracket is quite important. Okay. So I was aligning it against that corner. And the first thing I'm going to do is mill that little pocket, which should also cause the hole to break free. Got a little 3mm hole there that isn't quite going all the way through right now. Try this little operation right there. That's cool. Oh. Huh. That doesn't go through, and it's also not centered. Like, that's the center of the hole right there. Oh, how did that happen? That That also doesn't look as big as I was expecting it to be. No, that's the right size. It's just not lined up. Damn. And it's not as deep as I was expecting it to be. It's off by like a millimeter. I mean, I could drill that hole again from where I'm at here. I don't know why it's not lining up. At this point, I don't have that much to lose because this piece might be scrap anyway, so let's maybe make a toolpath for drilling this hole from this side. I was also realizing that I don't know if I can do the chamfer the way I was planning on because I'll hit a bolt with the tool. There's some bolts right here on these edges. So I might just not and just do that with a hand tool if I care. But yeah, let's make a 16th inch tool path for that hole. Can't I start that at the top of the model or the top of the stock? That's weird. This is supposed to be starting at the stock top and it doesn't. Oh, that's probably stock top minus the first step down. My step down's probably still way too high. probably way too conservative, but I don't want to dull my 16th inch tool more than I have to right now. Not like Delrin is that much of an issue, but it looks right in the simulation. Reed is asking if the hole lines up with the PCB on the other side. I mean, the other side, everything lined up. I'm not going to just take it off to check because it's already on there. But I'm going to cut the hole and then just take it off and look at how everything lines up and try to figure out what went wrong, assuming things are wrong. Because it looks like everything on the top is just about 1 millimeter off. So, yeah. I'm going to take it off and do a post-mortem. I just want to do this cut first. Tools. Yeah, I realize I could widen the hole, but like I don't want to do that. I don't want a hole there that's like way too big, and I also, if I have an offset problem, I just want to get to the bottom of that. So yes, I realize there are other solutions, but this is the one I'm choosing. I'm sure I could have also told it not to do a full retraction between each pass. Camera asks how I keep my cat off my keyboard. I mostly don't. Yeah, there's not really a good solution to that as far as I'm aware. I try to lock my screen or set the KVM to an unused channel or something like that. Oh, well, yeah, I mean, it looks fine from here. Maybe I'm just imagining things. You know, it's like also possible there was just some fuzz that made it look like that was where the hole was, and actually I'm fine. I might just be panicking before I've actually determined for sure that there's a problem. Anyway, so the only thing I wanted to do here maybe is chamfer the edges, but I think I'm gonna not, because I don't think I can do that without hitting these bolts here. I could fixture it differently and then chamfer it, but I don't think I care enough. So let's just pop this out and move on with life. I need a thinner spudger. Face recognition. Yeah, I tried that actually. I tried one of those face recognition login cameras, and it actually did not work very well. So I'm not using it right now, and now it's in the pile of gadgets to tear down. Actually, I think I've already taken it apart, so like it's more like gadgets to repurpose. Oh yeah, they lined up fine. I was just panicking over nothing. I think what I was seeing was like a burr on the plastic that looked like it was the center of the hole, but actually the center was fine. So I can't quite get this. So there's the PCB side. That was the hole we milled first, and then we milled this pocket, and then the contour, and then flipped it over. And yeah, so that thing on the left, I thought that was the issue, but the hole is actually centered as far as I can tell. And the screw that would go there is one of these. So yeah, it could use a bit of a countersink there, which I think I might just do manually with a either a drill bit or a deburring tool, which is how I'd probably countersink, or how I'd probably chamfer the edges of this whole thing. But we can wait. That might be easier to do once the wood part's assembled too. Yeah, that's a nice idea. Have a cat mode where if you just mash all the buttons, it disconnects everything. Although I pilfered the GPIO that's used for the enable pin, so I need to get that back somehow. I was worried about this bottom being too thin, but it's not too thin. I forget how thick it is in the model, but it's like I want to say it's like 1/3 of a millimeter or something, and it feels fine. It doesn't feel wobbly or anything. It's great. Nice milled Delrin. And this part is a little bit flexible, but still strong, which you wouldn't get with acrylic. I'm pretty happy with this design so far. Cool. Well, let's go back to the computer and make a tool path for the wood. So the wood is going to start out as a piece like that. Yeah, so that's going to involve removing a lot of material. Ah, it looks just like the CAD model. Except for the chamfers and the countersink. Yeah. I could totally engrave something in here too if I wanted to get fancy. even just this pocket basically makes it a usable device, because it no longer wants to tip forward when I press the buttons. All right, let's go back to Fusion 360. All right, so that was our second milling setup, third setup. So now we're making this. Bit more complicated. So one way to do this would be to start out by milling, like let's say we started by milling this side. We could mill down, you know, well, if you look at the height of this whole thing and compare it to the height of the block, I think we've got a decent amount of extra material. This block is 26 millimeters thick. How thick is this? $17 millimeters. So, you know, we can face the faces pretty nicely. The first pass, then we might, I don't know, like what are the constraints here, first of all? Like what's hard to do here? I need good access to anything that I need the 16th inch tool for. I also need good access to anything I'm using the chamfer tool for, which I think I might want to do this chamfer on the mill. This is like more of a serious chamfer. I don't know. I've got this deep hole on here, but I think I could just start it with the 16th inch. And then if I need the pilot hole to go deeper, I could just do that with a hand drill or a drill press. But yeah, these chunks of wood are great too. These are just like discarded. This is literally furniture that was in the trash, and I just got some pieces of wood from it. So I designed pretty much all this to be cuttable with the 1/8 inch tool, which is nice because it's long. I can just plunge it down into pretty much all this without worrying. But the 16th inch tool is not very long. I think it's only like 8 millimeters long or so. So I might be able to get the 16th inch down into here, but milling those from this side is a bit iffy. I'd much rather mill this side. So I think I want to do this side first, and then face everything down. So imagine the top of the wood is like up here somewhere. Face that down to a level of maybe there-ish, and then flip the whole thing over and align the edges of this milled piece to the bracket and use that as my coordinate system for the backside. So let's do that. New setup. Milling. What is my stock? Let's give it our actual stock size. That's 108 by 62. Coordinate system is not right now. 26.1. XYZ stock box. Alright, so this is our hunk of wood. That's the milling coordinate system. That's the model. The model is in the middle of our wood, right where it's been all along. We just have to find it. Okay. Why does this keep going to 16,000 RPM? I'm just kind of starting with these default. Oh wait, we're not doing Delrin anymore. We're doing wood. This is much faster than the Delrin settings. I wonder what that is. Oh, this is birch. Birch is pretty easy to cut. Mahogany. I have no idea what kind of wood I'm using. It's pretty hard. Some kind of hardwood. So I don't know. I'll probably start with something like these mahogany feeds and speeds they've got. They're doing 10,000 RPM. Sure. Let's see what that's like. 10,000 and feed rate of like 500. I don't know about that plunge feed rate, man. I mean, wood is pretty compressible. Yeah, let's start there. So this is just removing all the extra material so that we get to the top of the model. I don't know whether we want to leave a little bit of stock here and then do a fine facing path, or whether this would be. I feel like if I don't know what the surface finish is going to be like, so I think I want to leave a little bit of material and then come back if the surface finish is good. And then if the surface finish is not good, change the parameters and then come back. Let's leave like an entire millimeter for now and just see what this is like. Oof. That's just taking everything off in one pass. Like, it looks like what it was doing is plunging right just past the edge of the stock and then using the side of the cutter to just go back and forth, which I think is fine, but I was expecting to see an option for how much engagement we want per pass. Step over is the radial direction. Yeah. Multiple depths? Oh, yeah. don't really know how aggressive this is going to be. This is a couple of passes. Well, let's try this, you know, pretty conservative. If it turns out this is like way slower than the mill, seems like it can take it, we can go faster. Let's do a very conservative facing pass first. Alright, I'm calling this step 0 because this isn't even really the real facing. This is my conservative, not quite facing pass. Okay, let's give this the same stock parameters. That was 108, 62, 26.1. Also, this is not an extremely accurate measurement of the wood, and the wood is not extremely square. So I do actually want the facing to take into account a little bit of additional material beyond what I've got. Yeah, stock offset. Five millimeters. Yeah. Yeah, just cutting off some wood, you know, as you do. Testing some feed rates. Man, it says this is going to take 35 minutes. Yeah, we probably will actually want to speed it up. So let's just consider this to be a feed rate test. I do need to clean this enough that I can attach the wood. It's still a little messy in there. I was having trouble getting enough air out of this because it was getting too cold. All right, this is going to be loud for just a sec. It's not going to be super clean, but I wanted the plate, or the spoil board, to be pretty chip-free. This piece of wood also has like a nice side and a pretty grody side. I'm going to put the nice side down because it's going to be more flat, and that'll be a more solid mount for the wood as I machine the top side. And once I do this top side machining, I'll have some really nice flat surfaces to reference. Okay, so some Nito tape. I'm being lazy about taking the tape backing off. I like to use a knife for this and kind of poke the tape backing and lift it so that I don't end up curling it inward, which can make it less flat. There's a lot of different ways to fixture stuff. Some people use hot glue for a lot of fixturing, which is kind of nice. I was also hearing about a nice method using painter's tape and super glue. But for this tiny mill, Nitto tape, which is what this stuff is called, Nitto, it's pretty good. It works for most things that this mill would be able to hold anyway. So I'm going to use the bracket to line it up out of habit, but this is not critical. Okay. Cool. I'm going to do a tool change too. Inch. There's definitely a little bad spot on the threads for this nut. Not really sure what to do about. Oh yeah, the camera in the mill is fun. They should come standard like that. Okay. All right, step 0. Tiny triangular file. Yeah, right. I set it 5 millimeters past the edge of the stock, which is maybe a little excessive. Maybe this isn't excessively aggressive, actually. This wood seems pretty hard. It's leaving these tiny little curls of wood between every other pass because of the cut direction. Yeah, this is going to take a little while. 30 minutes. If I had more of a wood shop here, we could use a planer to get this block closer to size before milling it. I don't know if we'd do better going a little slower and taking more off at once. Robbie's asking about the material. Yeah, I think all the tooling I've got here is carbide. Just turning this trash furniture into sawdust very slowly. If you want machining to go really fast, I hear foam and wax are the way to go. I've also seen wood go much faster than this though, like I could probably go faster on this machine even. I do think for a finishing pass I want to not be cutting in both directions. So probably smart to keep this to just a roughing operation. You can also get 1/4-inch collets for this machine, which I might want to get eventually. Yeah, that's a cool sound. Probably gonna do one whole air pass on the top side now. Yeah, that's not optimal. Yeah, it is interesting thinking about the life of materials and thinking about, you know, it is very different doing subtractive manufacturing, you know, having these solid chunks that you're whittling away and, you know, thinking about objects being inside them. Now we're getting some more engagement. There's going to be so much material to remove on the other side. This is going to take a while. I wonder if I can cut at a faster spindle speed. I don't really like this. Let's change settings. I think we're pushing a little too hard. I think we might be better off with maybe a faster spindle, a faster feed rate, and less cutting. So narrow, like shallower passes. Let's change this. Let's go up. Let's see if we can handle 0.2. It's a lot more passes, but also a faster rate by quite a bit. It says this is going to take an hour and a half. Well, let's just see what it's like. Yeah, I think we want to go faster than that. That's like, what, 600? Really? That's supposed to be 800 millimeters a minute. Let's see what this looks like. Oh, that's interesting. Combining additive and subtractive, maybe doing extruded. How do you pronounce that? Is that acetyl? I know that's a plastic, like a high-performance plastic that's used a lot for machinable parts. thinking about the other side also. There's going to be a lot of material to remove on the other side, and I think for that I'll be sticking it down on the top side. It's probably fine. Oh, okay, acetyl and Delrin are the same thing. I've forgotten that. That's cool. This is when it's nice to pay attention to where the machine is on the z-axis so that we know how far we are in case we have to restart the job. So it's very tiny on your screen, but it's 26 millimeters, or 26.05 in the Z. We're still in the air. Might poke around at setting up the next tool path while this one's milling. But I'll keep the camera mostly on this. So I'm doing a rough facing and then a fine facing. The finishing pass for this facing is just closer step over, and I'm not leaving any stock, but just one pass. Whereas this is a bunch of passes. And then I think next I want to start cutting out the rest of this piece. Can I do adaptive clearing on the outside of a part? Oh, I think I can. Oh, that's interesting. We're just coming in past the edge of the stock and then just going around in lots of spirals because I am not taking off much material at once. That's an interesting way to do it. I wonder how this compares to facing. Still not quite sure how the other side machining is going to work. Because, like, let's say I mill out, like, pretty much this entire exterior area down to a certain depth, and I flip it over, then I mill out the inside. Now I've got this part that's attached to this thing that's kind of hard to cut off safely. Instead, what if I mill it pretty much all the way out? Well, what if I mill out this entire thing on the top side? And then I flip it and I do all the machining with this attached to the bracket. Maybe that's the way to do it. This is nice. I'm pretty happy with the way it's cutting right now. I don't know, it's like building up some fuzz right next to the cutting surface, which doesn't seem optimal. But it sounds better. Oh yeah, good question. What am I actually making? So this is the wooden part that I'm trying to mill here. It's an enclosure for a little 4-button USB channel switcher. So this is where a kind of 1/8" audio style jack goes in. Oh, that's interesting. I hadn't noticed this weird little bit of... That is very strange. I don't know why that's there. But yeah, it's got room for 4 buttons and a circuit board. It lets me switch between USB, different computers to attach my USB keyboard and mouse to. I feel like those little curls I'm getting from having the step over be approximately equal to the tool diameter, which is the case for this roughing face pass, but not for the next facing pass. The other thing is my tool is not that long, especially with the bit fan on there. So I was thinking, like, mill halfway down, flip it over, mill halfway down. The problem with that, though, is, I mean, if I'm cutting through, now I've got this donut that's going to break free at some point and rattle around unsafely, which I can't do. So I'd have to leave tabs if I'm doing that, which is fine. It's just kind of weird, like, cutting and leaving tabs when the whole thing is not really supported that well. I don't know if that's a recipe for success. I could also just, like, mill away all that material gradually so that by the time I get to the bottom, there's almost nothing there. And then I just mill the last of that away. Fred is wondering if this supports bits other than the ones other mill sells. Yeah, totally. I mean, I've only got a couple of bits from their shop. I've mostly just been using whatever I can find. It takes standard tools. It's got an 1/8 inch collet in there now, but I think you can find a 1/4 inch collet that fits the same. I don't know what the diameter of the spindle itself is, but I think all those parts are standard. A router with a... No, I don't have a router. I also don't have the 1/4 inch collet, so like right now I only have 1/8 inch tools. This is also a very small mill. Like I don't know that I'd fit extremely large tools in here. I mean, I could sand it or something. I don't have a lot of tools that would make better work of this than what I'm doing right now. Yeah, those facing tools are great. They're just really big. I don't know, I haven't gone looking for exotic tooling for this mill, but I don't know of a facing tool. Like, I've never seen a facing tool that's this small. They might exist, but I haven't really gone looking. Also, like, I'm not really being limited by the amount of cutting surface I have right now. I think I'm being limited by the power of the spindle motor. But I could be wrong about that. I mean, it's also possible I'm just not pushing this as hard as it could. Like, it could be that I can cut this, like, 10x faster than I am right now. something about 10x on this mill. That's one of those things about this stream is there are all these things I'm doing once. Like, you've seen me do so many things once, and fewer of those things multiple times, and a lot of the time the conversation is around optimizing things that I'm doing once, and I'm not really sure what the point of that is. If I'm doing like a production run of a bunch of these things, then there's a lot of ways to optimize that. I could get different tooling. I'd probably just find a way to make the blanks smaller to start with. Like, I'd find space for a planer, or I'd go find somebody else with a wood shop with a planer, you know. But this is me doing the thing with the tool that I have right now, and so, like, picking different tools and being like, well, what if you had these tools? Like, that's a neat thought exercise, but that's not actually the same problem I'm solving here. Surface is looking nicer. Yeah, no, I'd be curious. I'd be curious what kinds of larger tooling this thing could have. But yeah, I think right now the limitation is the motor power more than the actual geometry of the thing. Because like it's pretty big for a quadcopter motor, but pretty small for a mill motor, you know. This first part is still a little bit deeper cut from the previous attempt at this. The other thing is I could just be milling all the time. If I'm milling literally 24/7, then it doesn't actually matter how loud my network attached storage is. Yeah, that's another good point. This mill, this tiny mill, while it's capable of doing a lot of stuff, is kind of optimized for circuit board milling. So it's not really optimized for chewing through large hunks of metal or wood or whatever. I saw the mills that they use to make this mill, and they're much larger. Getting a bit of an accumulation of sawdust. I think this slow spiral might be our next cutting path. So this tool path comes in at the edge of the stock and just spirals around 7 millimeters deep until we actually hit the contour we're going for. Do I need a rough and a smooth pass for this too? Yeah, let's call this a roughing pass. I don't know. feel like this doesn't need a separate roughing pass. Let's save this. So this fine facing will be step 1, and then this will be step 2. Fred's imagining a 10x scaled up version of this mill to make the mills, the Bantam mills. Yeah, no, I've been to the factory and they have these, I don't know what kind of mill it is. They look like shot bots, but I don't know if they're actually shot bots. They're big, like, sheet size things, but I think they're bigger than 4x8, the plywood sheet size. Maybe they are, but yeah, they're just big sheet size mills, and they just cut out lots and lots of these things out of HDPE. It's pretty neat. I can't remember for sure. I thought they were talking about maybe outsourcing the milling though, because I visited there when they were doing their own milling, but I forget whether that was something they were thinking about changing. But they definitely still do the assembly and QA pretty nearby. I'm looking forward to the surface finish on this project. It's looking really smooth so far. I think I want to do the chamfer and then the 16th inch. Actually, I should do a rough clearing with the 1/8 inch tool of these holes next. I'm actually kind of digging this computer-aided machining tool. Like, Fusion 360 is the first tool I've used where the CAM and the CAD are in the same package, and it is really nice having, you know, kind of first-class objects for everything instead of having to move files between different systems for that. Hmm. Stock top. Oh, see you later, James. Hope you sleep well. I hope your mood's been improved a bit. It's nice. Yeah, so I think this is an alright way to get these holes cleared, and then I'll come in with the 16th inch tool and do maybe a shallower pass up here to get the corners. This is leaving a 0.5 millimeter, which seems alright. Maybe a little less. So much sawdust. So this operation here will remove most of the material. I think I want to use another adaptive clearing up here with a 16th inch to just get whatever's left. These are kind of conservative settings. Let's maybe turn the spindle speed down a little. I thought adaptive clearing knew how to only remove the stuff that a previous pass left behind. Oh, derived operations, is that what I want? No, that's not what I wanted either. I mean, I can set that up other ways, like... Hey, Tuka. They don't even fit on the screen. This is a 1080p screen and they don't fit. Alright. Yeah, we could head back to the computer a bit. The milling, I guess, is not as interesting as the cam right now, huh? Alright, so here's what I had set up so far. Yeah, those are the Delrin setups. Here's the wood. So we have this is the facing we're doing right now. This is the rough facing pass. Then here's fine facing. And then, I'm not as sure about this one, but I think what we're going to do is go in on the side of the material and then clear out in a big spiral until we reach the actual edge here. So this will leave like a square of wood below this, and then the top of this will start to be the actual shape we're going for. And then I wanted to clear out these pockets. And again, I'm not going all the way down, I'm only going 7 millimeters down. Just because I want to kind of meet in the middle, because that's what my tools are not very long. So I'm doing that once with the 1/8 inch tool, and then coming back for the corners with the 16th inch, and that's what I was just working on. So this is 2D contour with rest machining set to get anything that an 1/8 inch tool would have missed. Which seems right. I was just trying to get the heights right. So now we're going from model top down 7 millimeters past the contour. That's even maybe a little much. Oh, that was only 3 millimeters. Really? Okay, even 2 millimeters looks like a lot. I think that's plenty. In fact, most of that is wasted. Let's only go like very slightly below that. 1/2 millimeter should be plenty. Oh wait, was that positive 1/2 millimeter? Yeah, negative 1/2 millimeter. That's better. Okay, let's export that. Then let's do the chamfer. setting feeds and speeds, guessing feeds and speeds. Just going to start with the same settings we've been using elsewhere for the chamfer tool, but maybe go a little slower. Now, which contour do I want? This one, I think. 'Cause that's where the point of the tool wants to be. Not really confident about this because I've gotten this wrong before. I mean, I haven't done a lot of chamfering, and I've certainly messed this up, so I will want to carefully look at the simulation of this operation. I don't really know what this model versus geometry distinction is. Let's find some documentation. Oh, hi. Hi, Nick. Hi, the current source. Can you... Why is this a blog post instead of documentation? Guess that was our first facing pass. Cool. Definitely need to vacuum this out. The mill is full of sawdust. Yeah. I could have actually probably used to clean out halfway through the job even. Now there's sawdust in my coffee. Oh, weird. The vacuum cleaner completely breaks my wireless mouse. I was just trying to move the machine so I could vacuum it in different places. Save the compressed air. I think this is clean enough for now. Alright, next this will be a second facing job. Very similar to the first job, just I was a little worried about surface finish quality. Let's look at what we got. It looks great so far though, so maybe even what I was considering a roughing face. Oh, looks fine, but it doesn't feel perfect. I think the surface finish will be improved by doing a proper finishing pass. So let's see if that's true. Okay. Says this will take 10 minutes. Left a bit more space between the fine and coarse than I expected, huh? This is maybe a bit too much. Yeah, let's break this up into a couple of pieces actually. This is more material removal than I wanted on this pass. Multiple depths. Whoa. How much material is this supposed to leave? Oh yeah, that was leaving an entire millimeter. Yeah, if I was doing this all over again, I'd probably configure these two jobs a little differently. It's a little too much. Ooh, cool. Finishing step down and maximum step down. So maximum step down will be about 1/3 of what we were just doing. Finishing will be about 1/10 of what we were just doing. Oh, and you can set a separate finishing feed rate. That's cool. Yeah, let's do that. All right, wood, step 1, facing. Why does it say this is going to take 46 minutes? That step over, and we can optimize that a little. Let's try that. So we're going to catch up with the aborted mill from earlier, and then hopefully we'll be leaving behind a slightly nicer surface. So the coarse operation before definitely should have come closer than 1 millimeter. I think I was just not sure whether it was going to even work as well as it did, so I wanted to leave some room for another attempt. But yeah, 1 millimeter is way too much to take off in a finishing pass. It's looking nicer so far. I'm seeing it through this dusty window, but... So if I remember right, it's going to be doing 2 passes roughly like this, and then a 3rd pass which is finishing, and it'll be going faster and taking off very little material. Given how much this wood seems to benefit from a finishing pass. Yeah, I don't know. I don't know whether the next sort of spiral contouring operation that comes in, I guess that's not even contouring, that's like adaptive clearing on the outside of the part. I don't know whether that's going to be too much or not enough or what. The base for this switchboard is already pretty useful. It's holding the circuit board pretty well. This is the Delrin piece that we milled earlier. Oh yeah, good question from Morgan, who's wondering how I'm going to fixture it when it's flipped over. I was planning on aligning the edges of the actual box to the fixturing bracket on the spoil board and then using tape on that top surface. So basically the same thing I did on the Delrin piece if you were around for that part. I milled the first side in a kind of arbitrary position and then flipped it and then referenced it all to one of the milled edges, or to two of the milled edges. A lot of waiting for the machine. Not really sure what you mean by touching off again about the fixturing. The way the references work, the Z reference is always the spoil board. So you touch off every time you change tools, but like putting in a new piece of material doesn't necessarily involve touching off. It just involves having a good idea of what the thickness is of that part. But like in this case, we'll be facing the other side also, so like having the XY reference for that edge, having that be accurate is really important. The Z reference, like there isn't really a top of material reference to worry about since we're just facing off that material. Oh, touching off on the side of the piece. No, I don't mean that. I mean just. There's a bracket on the spoil board, which you can see. It's located accurately. So I would just slide it into that corner and sit it down. Which is maybe not accurate enough for some operations, but for this it's plenty accurate enough. And for circuit boards it's plenty accurate enough too. That's what it's designed for. And yeah, that's also exactly what we just did on the Delrin piece. Not a good idea to leave tools unattended, but I think I'm going to take a really quick restroom break with this in earshot, and I'll be right back. For my next trick, I'll be reassembling the sawdust into a block of wood. Morgan's asking if that would rely on the top and bottom being the same size. No, I'm using totally different coordinate systems. So, again, it's the exact same thing we did with Delrin. It's, the coordinate system I was using for the top side was based on the stock material, and the coordinate system I was using for the bottom side was based on the milling we did on the top side. And yeah, the wood is definitely not the same size on the top and the bottom. It's just like rough cut with hand tools and non-accurate power tools. I started cutting it using my scroll saw, but I broke a blade, and it seemed like it would take less time to finish the cut with the hacksaw than to find my scroll saw blades. Yeah, I had to go pretty slow on the scroll saw, and I still ended up breaking a blade because I probably had the wrong amount of blade tension and the blade was old. I wasn't too fussed about it, and I know I have more blades, I just don't know where they are right now. I need to do more organization in that part of my shop, for sure. I gotta make more things out of milled Delrin. This just feels really nice. Guess I can go ahead and do the hand chamfering. Cool. Just use the deburring tool to make a bit of a countersink. Seems fine. I might do more later, but that's fine for now. Easy to take too much off with this. Have to be very, very gentle. feels pretty good. Oh yeah, good question. How are the overlays on the DSLR escaping the bounds of the shot? Chroma keying. It's a combination of chroma keying and a very slightly different color in the center of the frame. Silly OBS tricks. Yeah, I use a mask in OBS to very slightly change the color of anything that's in the frame, and then after that I use a chroma key to take anything that's still pure black and turn it transparent. So entirely silly OBS tricks. Camera is not doing anything special. What? Did the G-code just try to turn off the spindle and turn it back on? I'm not really sure what just happened there. I think we're on the finishing pass. It's taking very little off. Oh. My live stream, I do some interesting things with OBS. I feel like the most extreme OBS stuff I've seen is probably... Actually, I don't know if they use OBS. I've been assuming that Games Done Quick was all on OBS, but I'm not really sure. I don't know if we're on the finishing pass yet. I thought the finishing pass was going to be at a higher surface speed. I'd be interested to know if they are using a custom OBS plugin. I've done a little bit of work on writing OBS plugins, and it's interesting. I'd be interested in doing more of that. But most of the problems that I think I would solve by writing an OBS plugin, I actually end up solving by using the browser plugin. So far, the stuff I've been doing that actually requires writing an OBS plugin has been like processing the video in real time, like what I'm doing with my Tuco Flyer computer vision. Either that progress bar is totally wrong, or it's about to start the finishing pass. It'd be cool to make like a wind instrument on the mill. Very tiny one. Like an ocarina. I guess the progress bar was just wrong. Okay, that was the finishing pass. Let's see how it did. Ooh, oh, it feels great. Yeah, that's the stuff. Let's clean this up a little. So, nice and smooth. Very dusty. next? Okay, that was step 1, facing. Step 2, contour. Oof. Yeah, and I'm really unsure about this tool path. I don't know why we have all these retractions. Well, let's try it. I have a feeling we'll need to tweak this and restart it, but let's see what this is like so far. Yeah, that's too much. Well, it's hard to tell whether it's too much on each pass or whether this is just an issue of the material not being at all square. So let's figure out what the retractions are from and add some stock margin or whatever it's called. I don't know how I do that here. I mean, we might just do multiple passes in this orientation. The whole thing in a pocket operation? I don't know what you mean. Mm-hmm. This looks like it's gonna take forever, right? Let's see what that looks like. That's probably going to take a really long time, though. Like, this says it's going to take 3 hours to mill. I just want to see how this looks as far as feed rates and how much material is coming off and all that, but I don't think I want to wait 3 hours for this part. We can take off more material. I feel like the height is about right. Maybe more radially, more material in the radial direction. That. I don't know if I need a separate roughing and finishing pass here. Stock to leave. Me too, go. Yeah, I think I do want to leave some stock. Kind of want to just make a copy of this and then modify it. Maybe that's what derived operation actually is. stock to leave. So 0 axial stock and 0.1 radial stock. And then we can just do a contour to clean that up. Let's go ahead and get this started milling, and then I can work on the rest of it. Let's delete these. I should really name these. Rough facing. Finish facing. Rough outline. Rough outline. Now it says 1 hour and 38, which is it's a little long, but maybe not too unreasonable for what we're asking it to do. We should pause this in the middle a couple times and vacuum. Reed's wondering if I could constrain it to only mill the corner I'm using for locating. I could, but that's not what I want. I want to mill the whole half of the box. I'm not just milling this for locating purposes. I think that's the direction where it's cutting against the grain. It doesn't sound great going along those y-axis sides, but it looks like it's cutting fine. I mean, if we were trying to optimize this for a short production time, first of all, we wouldn't be starting with a blank that's way too thick. We'd be using a different tool to make the blank thinner. If we were still trying to optimize for production time, like, there isn't really a way out of having to face all that extra Z height off at some point. Like, even if you could manage to avoid cutting that right away, it would still get in the way, cutting the rest of the part. Like, this is going to be, like, the wood that's coming off right now would have been after flipping the part, like, inside the spoil board. So there's nowhere for this wood to be unless we were going to fixture it differently. Like, the other thing to do is to just pick a blank that's a closer match to the size we want, right? And in fact, you can see the tooling for that in Fusion 360, where if you have a model, you want to mill it, you want to cut a blank for it, it has a way to take the bounding box and round it up to the nearest, like, 10 millimeters or something, and then give you those dimensions. So, the main reason I didn't do it that way here, well, in the X and Y dimensions, I can cut that pretty easily with a saw. I just don't really have that set up right now, and it's easier to wait for the mill right now than to move around a bunch of stuff and find a saw blade and get the saw set up. That won't be the case once I've done more organization, but right now things are disorganized, and it's easier to wait for the mill than to set up a different tool. And as far as the Z height, I don't really have a better way of doing that. I could just press it up against a disc sander for a while, but I only have a tiny disc sander here, so I don't know if that would actually work better. Oh, that's what the retractions were for, just a little bit of extra corner radius cleanup. Interesting. Emily says the hardest part of milling wood is resisting the temptation to lean in and blow the sawdust away. Yeah. Camera is covered in sawdust. Building a little like rice terrace or something. Yeah, I think I get what you're saying, Reed. I think the problem is if I machined this and I was using this bottom left corner in your drawing as a reference, the problem I still have is that the material down here is sticking up further than what I've machined, and then I flip that around, and that material is now interfering with the spoil board. Like, for that to fit, it would have had to be inside the spoil board. So it's just an issue of I need that material to not be there so that I can flip it over. But yeah, I think that makes sense. And what I was saying with fixturing is, if I had a different way of holding it, like with a vise or with like a specially made fixture or something, then maybe there's some other way of doing it. But the simple thing I was planning on doing was just taping it in the other orientation the same way I did with the Delrin. And to do that, I need the top to, like, I need to have the top pretty much all be at the same height and have that height not be, I mean, it doesn't have to be the same height, but I need the top of the model to be the tallest thing still. Oh wait, never mind. Sorry, I'm getting confused here. The facing operation we already did took off that piece. So, yeah, actually you're right. I was just confused about that. I was thinking that it would interfere with the other side of the bracket, but we've already got, like, the whole piece of stock is small enough to fit in the bracket. So, yeah, that would be an option. I would still have to mill out part of this though, because I think the other problem is that my 1/8 inch tool is not as long as my stock is tall. So even if I wasn't going to mill off all the rest of this corner into sawdust, I would still have to cut like a slot there. Yeah, I mean, it's something to think about if we were going to optimize this, but like I've been saying, there are lots of better things to do to optimize this, like use a smaller piece of wood. So far, the progress bar has not been very accurate. At least, I think the last couple things we did, it got like 3/4 of the way done on the bar, and then that was actually the end of the job. Just looking at the Z height here, it looks like we're about half done. Yeah, if I was only worried about the locating edges and not about the height of my tool, like this would be plenty of machining on the top side, I could just move on. But that 7mm that I chose was kind of a compromise between how much I'd have to mill on the top side and how much I'd have to mill on the bottom side. goes knocking bolts off the desk on his own now. I will say that it sounds like there's a lot of folks in chat who are interested in optimizing toolpaths, and so maybe we need to work on something where we're going to make a bunch of them, and it makes more sense to do the optimization really hardcore. I've mentioned this before, but I want to do more just making and selling physical objects from like a little independent store. And some of those things could be things that I resell, like stickers, but some of them could be things I make here, like on the mill, or the vinyl cutter, or the 3D printer. Oh wow, Tuke's doing a really great job at playing Bolt on his own right now. That's cool. Oh yeah, I do have Servo AF stickers on the Redbubble store, which you can find a link to in the stream descriptions. The Redbubble store is convenient because I don't really have to do any work, but I also don't really get hardly any money from it. So if I made, or if I at least like mailed out the stickers myself, and even more so if I made things myself, I could probably make more actual income based on that. Because right now the Redbubble thing is like, it's a convenient way for people to buy objects that they wouldn't otherwise be able to get, but it's not really a good income source for me. So if I made my own store, it might be better for both of those purposes. I'm sure there are better places to get stuff made. The thing with Redbubble is not that they're easy to... It's not that they're good at making stuff, it's that it's a convenient way to get stuff fulfilled. But yeah, it's not what I actually want, it's a temporary thing. For stickers, I don't really know where to get stickers made right now. There was a place I got them made in the past at, and the quality was good, but I don't really like the I don't really like who owns the company, and so I'd rather get them made elsewhere. Gosh, Tuco is just going all over with the bolt today. Yeah, I mean, that's a good point. Reed says that part of the fun with toolpath stuff is optimizing and making stuff faster. Yeah, I mean, it might be nice to find projects where that makes sense. I mean, for one-off stuff, the trade-offs are usually different because you could spend a lot more time and a lot of material trying to optimize the toolpath than just doing it in a more straightforward way sometimes. But yeah, it could be nice to work on stuff that I can then make a bunch of. I don't know. There's a comment that the stream would be better if the mill were quieter relative to my voice. Any ideas how to do that? Sure. I mean, I could use a headset. I don't know if that would help much. Jarrett suggests a notch filter. This noise is pretty broadband. How's that? I don't think that helps. What about that? Just like everything's underwater. How about that? That's pretty bad too. All the way up there, maybe? Yeah, I don't know if that was actually helping. What about... low pass? Pointier low pass? Yeah, the motor noise and speech frequencies overlap quite a bit. What about that? I don't know. It's kind of hard to tell if any of this is better from here. I feel like we should take a vacuum break on this anyway. How does that sound with the mill off? The low pass is pretty weird, at least to my ears. Hey, Tuco. I'm going to have to pause this at some point because it's getting kind of late here and it's going to start to be kind of inconsiderate to make this much noise. How much sawdust is there in my coffee? We can try a notch filter, sure. You want the notch instead of the low pass, or 937, huh? Can you still hear anything?
Alright, there's a pretty deep notch here at 937. Okay. It's a little hard to tell the difference because I'm hearing the mill in person also, but I'm glad that sounds alright to you. I'm glad I'm doing a separate finishing pass So this one is alright, but the surface finish could use some improvement. It's also really obvious what the particular non-rectangular shape of the wood is when you hear it go along all the corners. It's interesting, I didn't notice that much of a peak on the spectrum around this frequency, but I'm glad it helps. So it has 2 more step downs to do. A good question about the RPM. I think it's set to 12,000 RPM right now. $14,000, I think. don't follow how audio compression would change the frequency, but I'm curious. Just setting up some of the other tool paths here. So right now, okay, so let me just start from the beginning. So we did a rough facing pass. We did a finish facing pass. Now we're on the rough outline pass. Next we're going to do the finish outline. I should do this at multiple heights maybe. I don't know, I figured the finish would be better if I just do a single pass but take off very little material. So this should be taking off just 1/10 of a millimeter. And then a similar deal, these are roughing it out at multiple depths. Then I'm just going back with a 1/16 inch tool for the corners. And then finishing it with a 1/16 inch tool. And this is probably more passes than I need. I was trying to be nice with the 1/16 inch tool, but I keep imagining that this is the tiny thing that's going to break easily. That's the 64th inch tool. The 16th inch tool is actually pretty sturdy. So let's try that. Compression. Oh, you mean like MP3 compression, not like dynamic range compression. I see. What is this video that won't go away? I was trying to use 2D chamfer here, which one of the help documents was saying works with either modeled-in chamfers or sharp edges that you intend to break during machining. But now this other document is saying that if you want to chamfer an edge that's already modeled as a chamfer, then you should use contour instead and just go along the outside edge. All right, I can do that. That's just not what I thought this tool was designed to do. Oh, this is the last roughing pass. It's like we're getting close to having a part here. The sawdust leaks out through a couple of the holes in the front of the mill, and it's all statically charged and just kind of bunches up. Like that. the roughing pass. We should clean out the sawdust, but we could also go ahead and do the finishing pass, and I should also do a restroom break at some point, but I keep putting that off. Just go ahead and try that finishing pass. It's really short. Oh, we're plunging really slowly. It's unnecessary. Same amount of material removal there. The sound difference was just the grain. Cool. That was the contour finishing pass. Great. I'm going to take a quick restroom break and then we can clean this out and do a little bit more. Feels great. Yeah. Alright, what's the next tool path? So the next thing to do is roughing out these big holes with the 1/8 inch bit. I have no idea if this is going to be a good speed, so we're going to have to try it. So I've got this set to 14,000 RPM, 1,000 millimeters a minute. I think we were going to try to go very similar to this rough facing and take off material, or rough outline rather, and go quickly but not take off that much in any one pass. So this was 14,000, 1,000, and 300. Same here. And then this was, what? Optimal load here was 0.6, and then step down of 0.1. Wait, that wasn't 0.1, was it? Oh, 1, yeah, not 0.1. Big difference. An entire millimeter. That looks better. And how deep is that? 7 millimeters? Okay. Okay, rough holes around. What are you doing, honey? Okay, so these start at the top of the model and they go down 7 millimeters. Should be basically the same cutting parameters we were using for that exterior. So, roughing 1/8 inch mill, 17 minutes. All right, here goes. Oh, it's doing them not depth first. I guess that was an option I could have chosen though. It's very satisfying how flat the bottoms of milled pockets are. It's a little weird to me that the rate that it updates the mill position at is so much lower than the frame rate. I was just noticing, like, the UI is actually running at, 60 frames or whatever, and there's some animations at that rate. But the mill positions are probably just streaming back over the serial port, or USB port, without interpolation. A lot of this depth is kind of overkill. Like, I need to reach the, like, once I flip this over, there'll be a pocket that I need to reach the bottom of. And in order to reach most of that, like, I don't know, like, this depth doesn't actually have to be as deep as it is. Oh man, I should buy some beer. I'm probably out of beer. That might be what I do after the stream finishes. I want to get all the topside milling done if I can. I don't know if that's like a perfect stopping point, but it'd be kind of nice. The other thing I could do, which might be awesome, is that now that I've got the top side milled, I could take this out and take it back to the scroll saw and cut off most of the excess, which would make the rest of the milling much easier. Assuming I can find a scroll saw blade between now and the next stream, which I think I can. So if I were designing this workflow to include the like scroll saw or a table saw or something like that, one way of doing this would be to do the facing operation, then just do a contour, and then you end up with the contour and then a bunch of waste material, then cut through the contour on like scroll saw or table saw, and then that frees up those reference edges, and that would have saved some milling time earlier. These are all just different trade-offs between what tools you're using and what setup you're doing. And like right here while I'm streaming, it's easier to do things on one tool than to use a bunch of tools. But you know, if I was optimizing just for the amount of time it takes, then more tools would be helpful. Hard to tell how far down it is given these opaque models. Like, I don't think I can show the toolpaths without the material, which is what I want right now. Huh. After this, I've got a couple of things to do with a 16th inch, and then got a chamfer, and then we're done with this side. This looks like it might be the last pass. It's kind of hard to tell, though, with the camera angles. I do like how machining has different puzzles in it than 3D printing. It's nice to have different puzzles sometimes, you know. All right, I think that was the roughing pass. I think that's actually it for the 1/8 inch end mill on the top side. So the next step should be this corner operation. Let's just export these last few. So that was step 5, 16th inch corners, step 6, 16th inch finish holes. And chamfer. Holes. Okay, so now we can start to see what this is actually going to look like. We've got the kind of wider radius 1/8 inch hole, but then we're kind of opening up this very top with the 16th inch tool. And then opening it up just a tiny bit more with the finishing pass. And then chamfer. Oh, there's the chamfer, yeah. And the chamfer has a ramp step down. Okay. So let's do these corners. Change tools. Can is basically empty. Whole thing comes so close to the camera when it's doing the tool location. Okay. 16th inch corners. it's spending all of its time doing these really slow retractions. Let's not. Let's fix that. There's a keep tool down option here. I'm worried that that's going to go through my material from place to place. Oh, that looks right. It's not going through the material, it's going around and then up. Okay. I'm worried that it's still going to go back and forth between these a bunch. Maybe it isn't. Okay, let's try that. Oh yeah. Now it says 4 minutes. So the tool is going to go kind of horizontally here between corners. I think that'll be fine because that's just above the actual surface, and it's also kind of on the inside here. Yeah, we can't really just trust the simulation here because it doesn't know what our material actually looks like right now, which we could fix, but right now I'm just doing the simulation myself, I guess. All right, 4 minutes. Yeah, this looks good. This isn't even taking off much material. I could probably have coarser steps here. Yeah, this is taking off very little material. Let's go a little faster. Significantly fewer passes. Oh gosh, we're still plunging so slowly. If this weren't already so quick, I would certainly increase that plunge rate. This part is just so slow. was pretty straightforward. Just one more 16th inch toolpath. This one's just finishing up those hole outlines. Just one little cleanup pass on each edge. Definitely doesn't need to be plunging this slowly. Cool. I think we're ready for the chamfer. Tiny bit of fuzz on those top surfaces, but otherwise it's great. Probably something like that surface, like pretty much all these surface finish issues are things that you can optimize by changing speeds and how much material you're removing at a time. And oh. Okay. New tool, 80 degree. Very pointy tool we're about to plunge into the bed here. Oh, we're plunging so slowly. That's better. Increase the speed and also added a little bit of offset so we wouldn't be poking the very tip of the chamfer tool right onto the corner. Hey, Duke. Starting with an air pass, as is tradition. It's looking all right. I kind of want to give the tiniest chamfer to the button holes just to break that burr. Hold on. Surface finish there. Oh, it's fine. It's leaving me just a little bit of fuzz, but I think that's going to be maybe just, like, I don't know how I really get rid of the fuzz. Do I go faster or do I go slower? Anyway, let's just run that same toolpath again. I probably should have paused it instead of stopping it. I've done chamfering before, but I've certainly gotten it wrong. It's easy to get chamfering wrong. This is good. I'm going to do just a tiny, tiny chamfer on the buttonholes. So, the step that I was just doing, that was actually a 2D contour because the model already had a chamfer. But I think what I want, if the model does not have a chamfer already, is 2D chamfer. Great. Yeah, just a little bit of fuzz, but otherwise good. Maybe a finishing pass for chamfer would be the way to go. Like, maybe I was taking off too much material. Chamfer width. Tip offset 0.5. Width 0.25. Maybe less chamfer. Let's try an extremely subtle chamfer. I'm worried that it'll be too much. Oh, that's just right. Tiny little chamfer. Yeah, I'm thinking that chamfering the Delrin might have been cool also, but I would have had to fixture it a little differently to do that without hitting the bolts. Alright, I think this is good. Let's take a look at this. Just kind of rubbing the chamfer with my fingernail will get rid of the fuzz, so I'm not too worried about the fuzz at this point. Oh, that's great. Let's actually take this out of the mill. Yeah, I don't see anything else to do to it. I didn't use too much tape this time. Man, I should do more little milled objects. I really like the look of this so far. That feels really good. A little bit warm too. All that gross side of the wood that was nasty, it's all chopped up into sawdust now. So then the interior, that's going to be this part. So once the rest of this is milled, this will fit on top of there. The buttons will fit through those holes, which you can kind of see them line up that way, but you know. And yeah, so that's about it for this stream. We've got top half milled on this wood piece and the full Delrin thing milled here, and slightly cleaned up by hand, but mostly just milled. Well, yeah, I'm going to wrap this up, but it looks like we've got probably one more stream or so on this project. Can get this to a point where I can just wrap it up into a tidy little package, but as usual, we've got a bunch of other things going on. It's always tempting to just, you know, kind of put full steam into whatever project seems closest to finishing, and so, because it's nice to actually get stuff done, but there's also a bunch of other things we can do. I can do the final vacuuming off stream, save Joel from that. Maybe I'll walk somewhere and go get a drink or something. All right, well, thanks so much for hanging out. I will see you on the next stream, and we can do some more making stuff. And thanks a lot to all of the patrons and everyone who sends in packages. And I'm, as usual, just overwhelmed with how much support I get on these streams and on the videos I make. So I want to make sure that I can do my best to do what I can for all of you. So
I'll see you all next time. But if you have any ideas for what you'd like to see, or how I can make your experience a little bit better, I'm all ears. See you all next time. Happy hacking.